All right, we're going to do a quick review of last night's homework, which is just simplifying these radicals. 72 is 9 times 8, so we're going to write it like this. 8 can be broken down again. Square root of 9 is 3. And the square root of 8 we can break down into 4 times 2. So this is really 3 times 2 times the square root of 2. So the square root of 72 simplifies to 6 root 2. The square root of x to the 5th is x squared times x squared times x. Those multiply to give you x to the 5th. So this is really x times the square root of x. So the square root of x to the 5th simplifies into x squared square root of x. Square root of 24 is 4 times 6. And 9 is just 9. So the square root of 4 is 2. So this would be 2 root 6 over 9. And 18 is 9 times 2 over the square root of x squared. So the square root of 9 is 3. The square root of 2 is just the square root of 2. And the square root of x squared is x. Remember, if you do have a square root in the denominator, you need to get rid of it. Moving right along. We're now going to multiply. Last night you worked on adding, now multiplying. So we just, like in equations, you can multiply anything together. So 8 times 6 is the square root of 48. It might not be super helpful to get so excited and do that because we still need to simplify this. So let's rewind and think about how we can break these down. So 8 is 4 times 2. And 6 is 3 times 2. So the square root of 4 is 2. And the square root of 3 is going to remain 3. And the 2 square roots of 2 is the square root of 4, which is another 2. So remember, 2 square roots that are the same thing cancel each other out. So this would simplify into 4 root 3. If you did multiply it across and get 48. Hopefully you know that 48 is 16 times 3, or you can break it down in smaller methods like doing 8 times 6. But regardless, this is what you're going to end up with. So 2 root 5 squared is 2 root 5 times 2 root 5. So root 5 times root 5 is root 25, which is just 5. So this is really 2 times 2, which is 4, times 5, which is 20. And in the last one, we have root 3, root y. 12 is 3 times 4, and then we still have this root y. So square root of 3 times square root of 3 is the square root of 9, which is 3. Square root of 4 is 2, and square root of y times the square root of y is the square root of y squared, which is y. So this answer is just 6y. In this problem, we're going to need to distribute because there's a parentheses with a subtraction sign. So we have 7 root 3. You always want to put your radical sign in the back. Minus. Now you can multiply 8 times 3 together, but you could also just leave it right next to each other because we need to break that down and get it in simplest form. So 8 is 4 times 2. So this really all simplifies to 2 root 6. 2 because of the 4. And root 3 and root 2 are left over. So root 3 times root 2 is 6. And over here, we have 7 root 3. Since these are not like terms, we cannot put them together. That root 2 and root 3 make a root 6, so that's our final answer. In this one, I'm going to go ahead and multiply 8 times 2 because 16 is a perfect square root, which is 4. You don't have to. You could just break the 8 down, and that's fine. And then again, 2 times 18 is 36, and that's another perfect square root. So in this case, it's easier to multiply them out, but it is not necessarily always the case. So if something gives you a perfect square root, multiply them. If not, just break it down. All right, back to the distributive property, or that FOIL method, first, outer, inner, last. So 3 times 2 is our first one. That's 6. And then the outer, we have 3 root 8. That root 8 is going to need to be simplified. And then the inner, minus 2 root 8. If you're losing that negative, you might want to make it plus a negative. And then the last, we have a minus because of this. And root 8 times root 8 is root 64, which is 8. So this is 6 plus 1 root 8. We don't even need the 1 because we need to put our like terms together. Minus 8. All right, well, 6 minus 8 is negative 2. And root 8 is simplifiable. This is 4 times 2. So our final answer is negative 2 plus 2 root 2. We cannot put those together because they are not like terms, so we are done. In letter B, you again have to FOIL this one. Don't be alarmed and just square both terms. There's that plus in the middle. So you have to do your double distribution. So 4 times 4 is 16. 4 times root 3, 4 root 3. Root 3 times 4, another 4 root 3. And root 3 times root 3 is root 9, which is just 3. So we have 16 plus 3 is 19, plus 4 root 3 and another 4 root 3 is 8 root 3. Root 3 is not simplifiable, so we're done. Alrighty, remember, square root's on the bottom. That's just not okay. So we need to get rid of it. And we're going to get rid of this by multiplying it by itself. What you do to the bottom, you must do to the top to keep the balance. So we have root 33, because neither of those numbers are simplifiable, over 3, because this bottom thing is root 9, which is 3. That's why we did that, to get rid of the square root on the bottom. Nothing else can be done, so that's your answer. Root 20 you can break down, and you should do that before you get that square root off the bottom. So this is really root 4 times root 5, which is 2 root 5. And on top we still have our root 13m. So now we're going to get that root 5 off the bottom by multiplying both the top and the bottom by root 5. 13 times 5 is 65. So the whole numerator is root 65m. And the denominator now is 2 times root 25, which is 5, which is why we did that, to get rid of the square root. So the bottom is just 10. 65 does not have anything that can come out of the square root that will simplify. So that's your answer. All right, there's something called a conjugate, and that's when you have this plus or minus. And if you remember the difference of squares, when we multiplied this out, the oi of FOIL canceled. The middle two terms cancel. This gives us a squared plus, that's a negative ab because of this, positive ab, and then we have our negative b squared. The middle two terms, when you have the difference of perfect squares, is always going to equal 0. So this simplifies to that. So if we have a square root and we multiply it by the opposite, see how one's a plus and one's a minus? The middle terms will cancel, which therefore makes our square root cancel. So we would multiply this by the square root of 5 minus 3, and what you do to the bottom, you do to the top. So this would actually simplify to square root of 5 times square root of 5 is 5. Square root of 5 minus 3 is minus 3 root 5. And then we have our positive 3 root 5. Holy cow. Looks better. And then we have our 3 times our negative 3, which is our minus 9. So the entire denominator, this cancels. 5 minus 9 is negative 4. And the numerator, we would just have root 5 minus 3. That would be our answer. Nothing can cancel. Taking that into consideration, let's look at root 8 minus root 2. This, I wouldn't even go about simplifying it yet. Let's just get rid of the square roots. So root 8 plus root 2. What you do to the bottom, you must do to the top. Since this is a minus, we'd have to multiply by the plus to get rid of the middle terms. So root 8 times root 8 is 8. Root 8 plus root 2. So root 8 times root 2 is root 16, and that's a plus. This is a minus because of this. Root 2 times root 8 again is minus root 16, so these are canceled, which is what we wanted. And then the minus root 2 times root 2 is going to be a minus 2. Square root of 4 gives you 2. So the whole denominator simplifies into 8 minus 2, which is 6. And then that whole numerator is root 2 times root 8 is root 16, which is 4. And root 2 times 2 is root 4, which is 2. So the whole numerator is 6. So ironically, this whole entire thing is just 1. If you saw that 8 simplifies into 4 times 2, which is 2 root 2, and then 2 root 2 minus root 2 is 1 root 2, that's why it's 1 as your answer. So I guess it probably would have been simpler to simplify the 8 first, but hey, who doesn't love a